Hi, have you ever wondered how to log your catalyst experiment metadata to Neptune? Welcome to one of the most exciting sessions of this event where I will show you how to connect Neptune to your catalyst experiment to improve your productivity and workflow as a data scientist or machine learning engineer. My name is Prince Canuma, and I'm a technical content writer focused on AI, and I am a developer advocate at Neptune AI. After this session, you will know how to connect Neptune Logger to your Catalyst experiment, which will help you to log metadata about your experiment at different levels of your experiment. Before I start, I just want to talk a little bit about Catalyst and Neptune. So, what is Catalyst? Catalyst is a PyTorch framework for deep learning research and development that lets you focus on hypothesis testing and takes care of the engineering stuff for you by creating abstractions and modules right out of the box, such as training loops with metrics, model checkpointing, advanced logging, and distributed training support. And now that we know a little bit about Catalyst, what about Neptune? What is Neptune? Neptune is a metadata store for MLOps, built for research and production teams that run a lot of experiments. It gives you a central place to log, store, display, and analyze all the metadata generated from your Catalyst experiments. Yes, we do have other like more integrations, which you can check on our docs page, a link that I will show you at the end. Now, enough of the chatter. Let's dive right in. I have two examples to show you today, a basic one and a more robust and customized example. Let's start with the basic. That illustrates you how easy it is to add Neptune to your code. So, what do you need to add Neptune to your code? Before, let's look into a typical training loop. So, on conventional, if you're using PyTorch, bare PyTorch, you would have a training loop that looks like this. You have a stage. This could be frozen or unfrozen, whether you're doing pre-training or you're doing you have some kind of stage here. Then on that stage you have a number of epochs, right? And then on top of that you have a loader, right? Or loaders, which is your training loader, your validation loader. And then you have your batch. So each loader has data inside it, and we take chunks of it, and this is our batch. It could be from anything from 1 to whatever number that your hardware handles. And then handle batch in a supervised training, this would be doing your forward pass on the model. Then it will be doing your, going through your loss, and then calculating the gradients and be updating the parameters of your model with your optimizer. Now, now that you understand this, let's look into our code. So you start off by installing three libraries that you need. First of all, Catalyst, second, Neptune, and then Cyotils, which will help Neptune log your hardware metrics automatically. So if the moment you install Cyotils, Neptune will start logging your hardware, meaning your memory, your CPU, and your GPU usage automatically. You could shut it down, and you can check that on the docs how to do that. But right out of the box, we take those metrics. So in order to do this, we do a pip install Catalyst and then Neptune client and Cytil. I already created an environment that already has done this, so I'll skip this step. You can go right ahead and install that. So Once you install that, we will start importing libraries. We have here Catalyst DL, right? This is the main object. You have, which is deep learning, and then you have a Catalyst dataset, Catalyst transformers, a normal order dictionary from Python. You have Torch, NN module, and Optim for optimizer, and then a data loader. Now, here we define our hyperparameters, we define our model, criterion, and optimizer. That's pretty simple. Our data loader, but then the magic starts here. So we talked about, in the beginning, I talked about different levels of your experiment. So here you have a supervised runner. So what is a runner? In Catalyst, you have this abstraction here, which is the runner. Inside the runner, you will see that when you call run, first thing it does, it calls run experiment level, then it calls stage level, then we have epoch level, then we have loader level and batch level. So our logger, right, our Neptune logger, takes data from the different stages here. And I'll show you how this works in a few. But just understand this, and the difference in a supervised runner, you only do the handle batch, which is doing your normal forward pass and your normal forward pass and calculating the gradients and everything. That's how you do that here. You have runners for different types of settings, unsupervised. But in this case, we have supervised, and the only difference is going to be how you handle your batch. Now, supervised runner, we already understand how it works. And then we have here our runner. Our runner has this dot train method. This method takes a model, criterion, optimizer, and then here's the one thing you need to do. It's very simple. In whatever Catalyst experiment you have, you just have to add this one line of code here, right? You instantiate Neptune logger, you pass in the project, you pass in the tag, and then we have the name, right? And just with this line here, automatically you'll get all your metadata at 2 levels. So in the basic, we have 2 levels. We are doing at the loader level, and we are doing at the experiment level. So let's dive in. We have our loaders, which is your train and validation loader. And here you have your accuracy callback. So interesting thing, whenever you have a callback, all callbacks in Catalyst automatically take data and send it to all the loggers in that experiment. So if you had another logger here, it will send data to that logger too. Then we pass in our number of epochs, parameters, and then we have log dir logs. So you could actually instantiate a checkpoint callback, but this is taken care of for you automatically in train if you pass in log dir. And then you have your indicator of what is the name of your validation loader and what metric you are using for your validation. And this is some other parameters. Now, the final thing in this experiment, so once you train your model, you send an artifact. So on the new version of Catalyst, Catalyst has added log artifacts, and our logger supports log artifacts. So when you call log artifacts, it automatically sends data to our logger, and our logger takes the path to that specific artifact and logs it into our UI. And you see here scope experiment, which is at the experiment level. So now let's run this. This one is the basic example. Okay, Python basic dot UI, right? This will take a few seconds to load. And once it does, it will give us a link. You see here, app Neptune .ai, and then there's a project name with an ID at the end. You click that and you follow that link. Let's start with a run. So we created a run, and you can see that it's still live because of this emotion, this animation here. So experiments, it's still relatively empty. Meanwhile, let's check other things like since we have utils, you can see here your CPU data, right? And you can see from step 0 to step 1, there's been an increase in percentage, and it's pretty much eating away all of my RAM. And here you could get some information, some logs of what's happening in your experiment. And I guess we are finished. Yes, we are. So we did finish. So now let's go back into our experiment. So here we go to all metadata, we go to experiment, and then you see here artifacts and epoch 5. So after we finish our training, we did send some artifact using log artifact. And that was our best model, right? So the log artifact took the best model from the last epoch and sent it to our UI. So here we have parameters. We only have a batch size and learning rate. And then we have train. So you saw there the train method. That's the name of this folder. And then inside train, we have training loader, right? And we have the validation loader. So if we go inside, this is the loader level, and we also have the batch level. So inside training, our training loader, we have the metrics of what we would consider an epoch over the training loader. But here in Catalyst, epoch is overall both training and validation. So it's separate in two folders. So you see here the validation accuracy going up, right? And you get this all from that one line of code. It already tracks this for you automatically using the accuracy callback too. Then we can also look at our loss. It's going up. This is not like a full-blown experiment, but yeah, the loss is getting worse. It's good. We could flag that and be like, okay, our loss is increasing over time, so there must be a problem. And this can help us debug our experiment. Then here you also have some hyperparameters from the optimizer. Now, this was the loader level, so one pass over the loader, right? And then we have batch. So each batch inside that loader, and you can see here, interesting. You can see here, if you zoom, you just have to do a click and then cover the area that you want to zoom. In this case, I just want to be here. So you see here that we have this line going this way, and then it has this straights, right? So why is that? So Catalyst has an epoch counter, right? A batch count, like a step counter. And that step counter counts both training and validation. And the reason is simple. So once you finish your training batch, it will stop. And for this straight line here, it's gonna be doing the validation side. So if you actually, when we go check the validation, you will see the difference. You see that for the validation graph, it has this small. It was from 6,000 to 7,000 something steps. That's why we have this small interruptions in our graph. But if you don't want to see it this way, you can smooth it out and see how it progressed over time. Same goes for the loss, right? You see here the training, the batch loss. And here's the thing. We are doing the batch over all epochs, right? All 5 epochs. So there will be 5 interruptions in this case, because we do one pass. This is one epoch over one full pass over the training loader. Then we do some validation in this straight line, and then we do another full pass, and then another full pass on the validation loader, and so on and so forth. Now, we've done the training part. We've seen the training part. Let's look at our validation. So first, we'll look into our validation loader. And we'll see here that the accuracy is also increasing. Super great. We can come here and also see that our loss is increasing, which is not great. Going back and one more level, so we can go into the batch, and I'll show you that difference. So as you can see here, from wherever, I think 6,000 something, 6,064 till 7,000, it was running the validation batch, and then it repeated the same pattern, but it's longer here because this is the time that our training loader occupies. Now, we've seen the metadata and how it's tracked, and if we want to really get a better visualization over it, we could smooth it out, and that will help us understand our graph a little bit better without all the distractions. So this is our training level, and this is our basic example. And one other thing is that Catalyst logs hyperparameters at every stage. So that's why you'll see hyperparameters here repeated. So that's our basic example, and we have seen how the run works. All the metadata first. Now let's look into specifics, right, of like all the charts that we have. So you can see here the training batch accuracy, and training batch accuracy 0.1. This is because the 0.1 is simply because we have top K, and if you look at the code, right? If you look at the code, top K is only 1. So in that case, it just becomes normal accuracy. Then here we have our batch loss. We have our learning rate, which remains static. We have momentum. And here, this is where we find all the charts from our experiment. So if you want to explore all the charts that you have in your experiment, you can just come to start charts. Here you have your CPU, as I showed before. Now, if you are looking for the code that I showed you in VS Code on my laptop, you can come here and just click here, and it will download the code, because Neptune takes a snapshot of all the .py file, the file that was used to run, that created the run. So the source file. And then we also track some Git information, like whether it's dirty, and whether the repo is dirty, and we also get some Git config information like for example, your last commit, and you could actually check out to your last commit using this part here. And you also have a notebook checkpointing, which is something you can explore using the docs later. Now, we have here our batch. We could create a dashboard, right? This is a custom dashboard that Camille, my colleague that helped me with this project, created. And here you'll see we have train accuracy and validation accuracy. And now you could see them side by side so that you can understand how what I was explaining later, but side by side. You could also have the same thing with losses. And we also have here another, this is a dashboard with all the batch metrics. And here you could have a dashboard with all the loader level metrics. And you could have them side by side here, the training and validation. And you could also have both the loader loss. You could also have the train and validation loader loss. So that's our basic example where I showed you how to log data at 3 different levels: at the experiment level, at the loader level, and at the batch level. Now, you've seen a run, which is the smallest unit in Neptune. Now let's look at the main UI and dashboard. So here you have the main UI and dashboard. You can, actually, let me show you from the beginning. You have all of this. You could add a column. Let's say I want to add a column for batch accuracy last. This is a column for all the batch accuracy. I can change the color of this column, right? And you could do this. You can do the same for all of these columns here. These are just suggested columns that we give right out of the box for you. Here we have our tags, and one cool thing is that you can move the columns as you wish and organize them in whatever way you want. Another cool feature is group by. So if you also log the name of your optimizer or the name of your model, you could actually group by a specific model. So let's say you have ResNet, and that will show you, that would group by ResNet all the experiments that have ResNet in them. And then we'd have another model and so on and so forth. And the same thing with optimizers. Now, here you have this beautiful view here, and we have our search. But before we talk about our search, let's talk about views. So you see here all runs, that's the normal one. And then right now, I told you we're going to do 2 examples. So we have the basic and we have the complex. So Camille was kind enough to create a search, create a view with a search using the search and persisted it. So here we have all experiments that have the tag basic, right? And if you create a view, let's say I erase all of this, you could actually just click on Save New and give it a name, and that will save that view. So if you are about to go on a meeting with upper management and you need to showcase specific things, you can create a view, a custom view that only shows that. And if you are going to present it to your team, your data science team, you can show more things, or you could show extra data. And you could have those views persisted just like so. So we have your basic, we also have complex, and we have validation accuracy, which is just finding all experiments that have the last accuracy, like the last step of the accuracy, with a value equal or bigger than 85%. And you can see here the lowest one starts at 87 and goes up to 93.75. Now, let's go into horizontal split. So this is run stable. You could go into horizontal split. In the horizontal split, if you click on this eye here and choose all on this page, right, it will show you all of these experiments in different ways. So, but the most impressive one that's going to be really helpful for you is going to be the charts. So you will see certain metadata compared here all together. So here, for example, we are comparing all the training batch accuracy from all of these experiments here, from all of them. But not all experiments have the same epochs, so you'll see some finish early and some go till the end. So don't mind that. Here you will find your batch accuracy 0, 1, same thing. You could also check your batch loss, right? Compared, all of them compared, and you can see which one was the lowest at a specific point. And you'll see that the color, you see here, this part here, where you see these values with colors, they do match the eye color here in the experiment ID. So if you're looking for a specific experiment, it will show you the ID, and also you have here ID. So that's how you can check them. And you also have compare runs side by side, and this same thing there, but here is with the full view, can help you compare those runs side by side and find out something interesting. But this is, I leave it to your creativity. You can choose whichever you prefer. I like the graphs. The charts are really, really cool. You could use side by side or a combination of both. Now, I've explained to you the search, right? How you can write the search, and the search is pretty simple. You could just say validation batch accuracy less bigger than 8 point, and there we go. We have our search. We could go a little bit higher if we wanted to. So if we go 90, you'll see that the last one will disappear. Yes, the last one just disappeared. And if I want to, I can save this as validation accuracy bigger than 90%. And it's persistent. So if I come here, you'll see that's still 85. And if I come here, I'll find all experiments that have accuracy with a set threshold. Now, we've looked into the dashboard. Let's jump into our complex example. This is our complex example. And here we do the same steps as the basic, but we do two things different. First, here we are using callbacks, right? And we are going to log metadata at 4 levels. So it's going to be experiment level, it's going to be stage, it's going to be epoch, and it's going to be loader level and batch level, actually 5. And callbacks start at stage level. So if we come back to our runner, callbacks start at the stage level upwards. And I will show you the logic behind this. So callback has these levels, including batch. Here, I'm just going to show you the important parts, which is our callback. Everything remains the same. So we have our on start, we want to log some images, right? On the stage start, we want to log some images. On stage end, we want to save a file, MP4 file with video stage level. And here our scope, so when you pass in the scope, it lets you identify or lets our Neptune logger know what stage do you want to save the data at. So, or what level in this case. Here we would have stage level, epoch level, and loader level. And that will translate into the folder structure or where the file ends in the folder structure. Now, here besides the callback, we also create a custom runner. Our custom runner, it just inherits from a runner, the original iRunner, and we just pass in a checkpointing path where our model is going to be, our device, our age params. Then we have an engine. Engine is pretty much responsible for all the hardware communication and certain deep learning strategies like distributed training and float precision, like half precision training and etc. So in this case, we're just using it to tell our runner what device we are going to use, which is CPU in this case. Then you'll see the same line that we have on our basic example here. You just have to overload get loggers and make sure it returns our runner, Neptune runner, and it's still the same. And then here we have stages, which is something new. And in stages, we have two stages here: train frozen and train unfrozen. And this will also translate into the folder structure. Get stage length, this is going to be the number of epochs or steps taken on each stage. And then get loaders, this is pretty much the same. Here we just, in the model part, here we just make sure that whenever our model is in the frozen stage, we make sure that we set our gradients, we freeze a part of our model, and when it's unfrozen, we unfreeze. And another thing that we do here that's super cool is the get callbacks. Here you can pass criterion callback, optimizer callback, and accuracy, which is going to send data, accuracy data to our logger. And this is what callbacks do. Callbacks send data to each and every logger that you have in your experiment. So if you had another logger here, it would send data to that logger too. Excuse me. All right. Here is our callback. And order is 1, so that our callback is the first in this list, like in this dictionary. When behind the scenes, our callback will rank higher, will be the first one to be executed. And then we have checkpoint callback, which I referred to in our basic example. There we talked about how logdir creates this automatically for you. But here you have to pass in your checkpoint. Now, this is how we handle the batch. Pretty simple stuff. Forward, and then we return a couple of things. Now we instantiate our run, and everything remains the same, including our log artifacts, which is going to send our best model to our UI. So now let's run this. Give it a second. Okay, there we go. Let's click on this link, Exata 46. Now, here, let's give it some time to log the data. Meanwhile, we can see where we are, still in the very beginning. Let's wait till our experiment ends. since we could actually track our metadata live here, you could actually see it live. So every update here is pretty much where the entire experiment is. Now, experiment level, we still don't have our metadata there, our best model, but that's gonna come in a few. Let's see how our code is doing. Okay, still running a bit slow. Okay, let's look into an existing experiment. So now going back, we can come here and call complex, and we could look at my previous run, and let's dive in right. So here we have artifacts as we had in our basic, which is the last line there. We have artifacts which logs the best model. That's pretty much the same. But now we are saving images. So on stage start, we are saving images. And you can actually look at these images individually. Here it's based on class, so image from each and every class is going to be grouped together. Okay, now let's look into train frozen. So we have two stages, train frozen and train unfrozen. Let's look into train frozen. This is now familiar. We have epoch, we have training, we have validation. So at the end of every epoch, we want to send our audio file, which I already showed in the code. So epoch 1, 2, 3, it sends our code, our artifact here. Now, let's look into our train loader during our frozen stage. Right? Pretty simple stuff. Accuracy, still the same, right? And the experiment in general, the structure remains the same. The only thing that's different now is that we have a frozen stage and an unfrozen stage, right? So now I'm gonna show you another cool thing with the dashboards. So we created a dashboard for the complex, frozen and unfrozen. Let's look into complex frozen. Here you will see the training and validation accuracy in the same graph, and you can see how they perform as time progresses. And you could also see the standard deviation. You can see the loss, how the loss goes. So in this case, the validation loss is lower, but if you trained a little bit more, they would converge. And we get some GIFs. Here it's like a summary of all of our entire experiment or entire stage. Right, you could create these dashboards just by clicking on add widget. You could add a chart, you could add images, you could have a value list, let's say losses or losses or accuracy, right? You say here, you see you could take all the data that's in a chart form and present it in a value list. And you could have file previews, which are pretty much displayed here. Now we can look at another dashboard, which is our complex data, and see, okay, so this is our class. This could be predicted classes. So we say class 0, which samples were predicted. And if we identify that one was not properly predicted, we could have a glance here. There are multiple use cases and combinations that you can create with this. Here is our unfrozen summary and with our file preview, which is our best model. Now, there you go. You learned a lot. So first, you learned how to connect Neptune to your Catalyst experiment. Second, you learned how to customize your Catalyst code to log metadata at different stages. And you also learned how to use Neptune to visualize, organize, and analyze your experiments metadata. So now let me show you the project link. I'll make sure it's pretty big. Here is our bit.ly, and this will lead you to this project. I already showed you where you can get the code from, which is source code inside a specific run. And here you have a link to the docs if you want to learn more about Neptune and other things that you can do with Neptune, which I mentioned in the beginning about the integrations. You could also find that here. And that's it. Thank you. Bye-bye.